Hello, let's talk today about how a particle will move in an atom. The point is that each of the particles is a particle that has electromagnetic properties. And due to the fact that such a particle moves, it creates certain types of spectra. And spectra can be of different kinds. They can be linear, continuous, discontinuous. We will also look at such spectra in the next lessons. But first I would like to familiarize you with what the spectrum of electromagnetic radiation can be. It turns out that such a spectrum depends on what is the wavelength, energy of this particle, and accordingly based on this there are different types of such a spectrum. In this case, the spectrum depends on its location. Here in this table that you and I see depends on the wavelength and on the frequency. The first wavelengths that are formed in the spectrum are radio waves, then there are microwaves, then there is infrared radiation. The visible light that we can observe is light, which consists of 7 colors, which we will also talk about in the next lesson. Furthermore, there are ultraviolet rays, then X-rays and gamma rays. At the same time, in order to determine exactly what this part of the spectrum will be, you need to know at what frequency such a particle will move and what it will do, emit energy or absorb energy. Accordingly, there are 2 types of formulas that show the dependence of motion on frequency and wavelength. At the same time, when particles are moving, they move in a very peculiar and interesting way in the form of a wave and in the form of a particle. This is the movement of particles, and the main particle that is formed during this movement is a photon particle. That is, it turns out that light is emitted and moves in the form of particles like quanta, and these quanta are a particle of photon. The photon particle itself is a particle that has dualism. That is, it is at the same time a particle having the properties of a wave, and on the other hand, it is a particle in itself. Moreover, I want to say an important thing, that such dualism exists in relation to almost all elementary particles that are in the atom. In order to determine with what energy a particular particle, including a photon, will move, you need to know the formula, which includes a number of parameters. This formula is called the Planck formula. This formula includes the energy that the particle will create. Therefore, this also includes lambda, which is wavelength, which is measured in meters. Then C is we have the speed of light, which is 3 times 10⁸ of a meter per second. And then we also include here frequency, represented by the symbol FF, is something that can be measured in hertz or in centimeters to the power of a -1. And here as well, we include Planck's constant, which is equal to 6.63 hundredths multiplied by 10 to the power of -34 joules times seconds. Moreover, the formula I provided is written in 2 different versions, one where both the speed of light and the wavelength are used. However, if you substitute CCC divided by lambda with F, you will end up with a shorter version of the formula. So what does this formula allow us to calculate? It helps us find the energy of a particle that is moving within a certain section of the spectrum being formed. As a result, the spectrum takes on a particular form, although it also depends on which type of spectrum is being observed for the specific process taking place. It could be either an absorption spectrum or an emission spectrum, both of which we will discuss in our next lesson. Nevertheless, the calculation formula looks exactly as I described it, but we will broaden our understanding of it so that we can solve more complex problems, again related to the electromagnetic spectrum. But for now, that will be all. Goodbye.